Now let's look at how to develop a project network. A project network is one where we have nodes and arrows. So nodes are represented by circles, and then there are arrows. Now we can use nodes to represent activities and the arrows to represent the relationship, the precedence relationships between the activities, and that would be activity on node convention. So AON stands for activity on node convention. But there is another way to develop networks, and that would be when the arrows represent activities and the nodes represent beginning of the activity and end of the activity. And that is called AOA network, activity on arrow network convention. Now we will not be discussing activity on arrow network. We will only use activity on node network. So you don't need to know how to develop AOA network, but you need to know what it means. What is AOA? AOA stands for activity on arrow convention. So here are some examples of how to set up activity on node network. So you have a relationship between A, B, and C, which says that A must be completed, only then B can begin, and B must be completed, only then C can begin. And that's what this section of an AON representation means. So if you have a representation like this, that would mean both A and B, activities A and B, must be completed before C can begin. If A is completed, B is not completed, then C has to wait until B also gets completed. Now this figure represents once A is completed, both B and C can begin at that point in time. Here C can begin only after both A and B are done, and D as well. So both A and B must be completed, and once that is done, then C and D can begin. Now this is the problem with activity on node network. Sometimes the arrows cross like this. We should try to avoid arrows crossing as much as possible by rearranging the nodes, but sometimes it is impossible to avoid such crossing. This one is C can begin only after A and B, but D can begin once B is done. It need not wait for A to be completed. Now here is another one where B and C can begin after A, and then both B and C must be done before D can begin. So some relationships require what are called dummy activities if it is done in an AOA network, and that is the reason we are not going to get into that. We are not going to get into dummy activities. We will only look at AON and not AOA. Now let's look at a full example. Okay, let's take a look at table 3.1 from your textbook, and here are the activities for a paper manufacturing company. So that's building a building. So each activity has a description, and then the immediate predecessor is given. So there must be at least one activity with no immediate predecessor. If all the activities have predecessors, that will be absurd. We cannot begin the project. So here there are two activities with no predecessors. So both A and B can begin at the beginning of the project. Then once A is done, then C can begin. D can begin only after both A and B are done. Now E can begin after C, and F also can begin after C. Now G can begin after D and E, and H can begin after F and G. Now H is the only activity that is not a predecessor, so H is the last activity. So start, both A and B can begin at the same time, and then C can begin after A, D only after A and B, and so on. Now H represents the completion of the project. Now if you look at this network, you can see that from start to finish there are several paths. So we have one path going like this: A, C, F, and H. and then A, C, E, G, and H. Then A, D, G, and H. Then B, T, G, and H. So there are several paths from start to finish. And if we have the activity times, then we can add up the activity times to see the length or duration of each path. And that's the way to perform a critical path analysis. Let's look at the time. So suppose if these are the times given for each of the activities, now when you add all these times, what you get is the total work content of the activities, not the project completion time, because some of the activities can be done in parallel. So the actual project duration will be smaller than this. So here are the different paths that we described just a minute ago. And when you add the activity times, these are the different durations. So this path takes 9 weeks, the next one 15, 13, and 14. The longest path gives us the project duration. And that longest path is also called the critical path. And the activities along the critical path are the critical activities. So any delay in these activities will further delay the completion of this path from 15, so the project will get delayed. Whereas the non-critical activities, for example, B and D and F, okay, if there is a delay there, then the path length will get further delayed from 9 to say 10 or 11, but this will not change, so project completion time will not get affected. Now let's work out a numerical example.